Fine, beta. Is the screen visible to you?
Yes, sir.
Okay, perfect.
Yes, sir.
Perfect. So guys, according to our discussion, yes, today we'll start a new chapter, sources of energy, and this will be the first lecture of this session, right? Okay, so if we talk about the energy, what do you know about the energy? Anyone?
So energy is something we use provided by the nature to power our appliances.
Okay, so it's something which is provided by the nature and through which we can do some work, right? You can say this thing.
Yes, sir.
Yeah.
Yes, sir. We
Okay.
can do some work by the energy.
Yeah, you can do some work by using that energy. In short, can I say that energy is the ability to do work?
Yes, sir.
If you
Yes, sir.
have,
Yes, sir,
We can.
it's like if you have the energy, you can do work. If you don't have the
If we
energy, you
don't have
cannot do the
energy,
work.
we can't do the work.
But just a second, madam. I'm not able to I'm not able to listen you guys. Just give me a second.
so is it okay now? Oh,
Okay, so guys, I'm audible now.
Yes, sir. You're audible.
Perfect. Perfect. So can I say that the energy is the ability to do work? See,
Yes, sir.
if I'm
yes, sir.
having the energy, I can do work. If I don't have the energy, I cannot do the work, right? It's just a very simplest thing we have. Suppose if you guys don't have the energy, you cannot study well, you cannot do your homework, you cannot do your exercise, and many other things which you are doing in your daily life. But if you have the energy, you can do all these things, right? Yes.
Yes.
Okay. So from where you are getting this energy actually? You guys are getting energy from where? Like, if you talk as an individual person, like if I talk about myself, right? So I'm getting my energy from the food which I'm eating, right?
Yes, sir.
Okay, so I'm getting my energy from the food. Similarly, other of the objects, or we can say other of the what we say like objects, let's say called it objects. So they will get energy from different sources. Okay, so as like we are getting energy, our energy from the food. Similarly, we also take energy from the nature. Like we take energy from the sun, we take energy from the wind. Okay, we take
Light.
energy. Yeah,
Light.
exactly. Light, sunlight. It's actually light is related to the sun. Beta.
Yes.
Light is
So
related to the sun.
hydro energy.
Yeah, tidal energy we can say, right?
So
Because of the
hydro,
fact,
sir.
sorry,
So
hydro,
hydro, sir.
hydro, right? So
Yes.
it's hydro energy we can say that by using this water we can convert the we are actually producing the electricity, right? So in nature there are certain various sources through which we are actually taking the energy. So if we talk about the energy, it is simply the capacity to do the work, right? Now, the main important point is energy stored in a body or a system is equivalent to work done by the body till whole of its energy has been completely exhausted. A body can do its work until the complete energy of the body get exhausted, right? It's the simplest thing. I'm capable to the work. I'm capable to do the work until my whole energy of my body, like the whole energy of my body, get exhausted. Okay, right?
Okay.
Uh, yeah, the third point we have is the most of the energy requirement is fulfilled from the fuels and the electricity. Now we'll talk about the fuels also, okay? And about this electricity, we have already discussed that what is actually electricity, right? So what is electricity? We have discussed in the previous talk chapter. And about the fuels, yes, we will talk about the fuels today in today's class also. Okay, so this is all about the energy. But do you know about the energy? That energy can neither be created nor be destroyed.
Yes, sir.
Is it the energy conservation?
So
Have
Yes,
you
sir.
conservation.
have you ever heard about this energy consumption?
Yes.
It is what? It simply says what?
Energy cannot be created nor be destroyed.
Can be
Exactly.
created,
We
not
have
be.
already studied about the energy conservation in class 9, right?
Yes, sir.
Yeah. And in this energy conservation, we studied about the concept that we cannot either create the energy or we cannot even destroy the energy. So, what to do with this energy? What we are doing actually?
So we can change its form, sir.
Yes. Perfect, Peter. We cannot produce the energy, or we cannot actually destroy the energy, but yes, we can convert this energy from
From
one
one
form
form
to
to
the another
another.
form, like as we are doing here. as we are doing here, as you can see here, initially the ball is having the potential energy because the ball is at some height.
Height, sir.
Yes.
So, but then when it comes down, it has kinetic energy.
Exactly. So as the ball comes down, you can see the potential energy is reducing, and at
The
the lower,
kinetic energy.
yeah, at the lowermost point, the potential energy is 0. So where this potential energy goes actually? So this
It converts to the
potential
form of kinetic energy.
exactly, beta. This potential energy get converted into the kinetic energy. So I must say that we cannot create the energy, we cannot destroy the energy, but we can convert it from one form to another. Also, you can see here, you have this water at some height. So that means I can say the water is having the potential energy right now. Can we say this thing?
Yes, sir.
Okay, so now if you allow this water to flow down, so the potential energy of the water is converting into the kinetic energy.
Yes, sir.
And this kinetic energy is further utilized to rotate this turbine. And if this turbine rotates, beta, if this turbine rotates, so actually this turbine is connected to a generator. This turbine is connected to a generator. And as this turbine rotates, okay, see what is actually happening over here. You have some water at some height, right? So it is having the potential energy. Okay, beta. Now, if you allow this water to flow down, so this potential energy is converting into the kinetic energy. And now this kinetic energy is further utilized to rotate this turbine. Okay, you can see here, it's turbine is something like this. Turbine is something like this. And if the water comes here, it will rotate the turbine. Okay, so the water is coming with some stream.
Generate electricity, sir.
Yes, right, exactly right. So the water is coming with some velocity. See, if an object is coming with some velocity, do it have the kinetic energy? I think yes.
Yes, sir, because it's in the ground.
Yes,
Motion.
sir. It's
in
in
the
motion.
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 Yes.
Yes,
So I'm
sir.
having a car moving with some velocity. It is having the kinetic energy, which is equals to half mv square. So similarly, beta, if the water is coming downward, it is having some velocity. So definitely it has some kinetic energy, and we are actually using this kinetic energy to rotate this turbine. Okay. And now this turbine is actually connected to a generator by this through this shaft. Okay. So shaft is actually what? Shaft is a cylindrical rod. Okay, shaft is what? Nothing but a cylindrical rod. So we actually connecting this turbine with a generator, and as the turbine rotates, it rotates the generator, and yes, this generator produces the electricity. You know now, you know this concept that generator produces the electricity. How it is producing the electricity? You know this? Any idea you have, guys? How this generator is actually producing the electricity? So, anyone? Any ideas? No. Okay. Actually, inside this generator we have a coil. Actually, you will study about this in your class 12. It's a part of class 12. Okay, it's something like we have a coil inside this generator, and as the turbine rotates, this coil is connected to this shaft. Okay. The shaft is connected to this coil, and as the turbine rotates, this coil is also rotates. And it is this generator we place in between the magnets. Okay. Actually, there is a concept of change in flux. So it's all about a part of class 12. We don't go into this part. But yes, just remember this part. This generator is actually producing the electricity. If you rotate the coil of the generator, it will produce electricity. And the same thing we are doing here. We are using the potential energy of this water to convert to produce the electricity. So what you are doing actually, we are converting potential energy into electrical energy, right? So what we are doing here, we are converting the potential energy of this water into the electrical energy, and this is the complete process for this. So how the generator is producing the electricity, it's not a part of this. It's not in our syllabus right now, but yes, it's a part of class 12. So don't worry about this part. We will definitely study about this in class 12. Is this clear to you?
Yes, sir.
This is all about the energy conservation. This is all about the energy conservation. It simply says that we cannot produce energy, we cannot create or destroy energy, but yes, we can convert it from one form to another form. In both the examples, you can see that we are actually converting energy from one form to another form, right?
Yes, sir.
Perfect. So let's talk about energy. What are the sources of energy? Basically, we have a lot of sources of energy right now: biomass, coal, sun, propane. See, these are also some sources of energy. Geothermal, okay, natural gases, wind, uranium. Okay, it's a part of nuclear things,
Yes,
right?
sir.
Hydropower, right, and petroleum. These are some
Sir,
sources.
sir,
Yes.
is there any difference between hydro and tidal?
Yeah, it's something like between hydro and hydral.
Tidal, sir.
But
Tidal.
I think both are related to the water.
So
Both are
because
related.
in eighth class, sir, we learned that it's called hydel power.
See,
Like
whenever you have this term hydro or hydral, it's something related to the water. So don't get worried over
okay,
this part. Okay.
okay, sir.
Yeah. So there are some sources of the energy. You can just go through these sources also. I've defined this by what is biomass. Okay. So definitions are also there. So if you want to go into detail, you can just go through the definitions also. Okay, better. See, no one gonna ask you about the details of this. Okay. But just for the knowledge purpose, if you want the details, you can go through the definitions also. The definitions are given, and I will provide you the PDF of this lecture. Okay.
Okay.
Okay. So let's talk about the good sources of energy. Now, how you define whether a source of energy is good or not? What are the basic characteristics of a good source of
So
energy?
it
What are
should
the
be economically feasible.
right? Yes,
So it should be readily available.
right, exactly. Yes,
So, and it should be easy to produce.
exactly. Yes,
So, and it should provide a large amount of energy for a small amount of.
it should be. I'm not getting you.
It should produce a large amount of energy per the.
Exactly. Yeah, it should produce a large amount of energy. This is the most important thing which you want actually, right? So the first thing, it should not be costly. Okay.
Yes, sir.
The second thing, it should be easily available. Then it should produce more energy, right? Should produce
Yes,
more
sir.
energy. More energy. Then it should be easily available. It's in a part. Okay. It should
So it
be
should be easy to transport, sir, to
okay.
different
We can say this. It should be easy. Should be easy to transport.
transport.
Oh, very good. Right. So whenever work has to be done, energy is needed. We know this part. Very good. Right. So this energy is supplied by a source, some source. We want some source. As like we human want food, right, for the energy. Similarly, we in order to do some other works, we want some sources of energy. So different sources of energy are used depending on the type of work, what kind of work actually you are doing. Okay, so that depends on that what type of work you are doing. So accordingly, you have to use the source. Like if you want to produce electricity, so either you can go with the hydral energy, you can go with the solar energy, you can go with the thermal plant also, right? So depending on that, what kind of work you want to do, you use the different sources. Okay. Some sources of energy may be good, whereas the other sources may not be so much good. We can find out whether a given source of energy is good or not by making use of the following characteristics, qualities of a good source of energy. See, there are certain qualities, there are something, some characteristics of the good sources of energy. Like as you can see here, it should be less costly, it should be easily available, it should produce more energy, right? Here are some certain characteristics or the qualities of a good source. So what are the characteristics actually? A good source of energy is one which would do a large amount of work per unit mass. See, but this is your point. It should produce more energy, right? It is the same thing, which would do a large amount of work. See, if someone having the more energy, it will do the more work, right? Yes.
Yes, sir.
If you guys have the more energy, you can do the more work. If you guys have more energy, you can do a lot of work. I can say this thing. So a good source of energy is one which would do a large amount of work. If it is doing a large amount of work, that means it is having more energy, right? So for per unit mass, it should do a large amount of work. Okay, that is the first characteristics for the good source. Second characteristics, it should be cheap and easily available. Okay. Third characteristic, it is easy to store and to transport. The fourth characteristic is safe to handle, but it is also important that the source which you are using, it should be safe to handle and use. Okay, so if something like sometimes it is very risky for us to use the sources of energy, like in case of nuclear plants. Okay, so nuclear plant is very difficult to tackle all these things because it's a case of like you know it's a very risky because in case of nuclear plants there's something nuclear fissions and the fusions. It's all in the part class. Well, beta. So just don't go into the depth part. Okay, but yes, it is very difficult to maintain a nuclear plant. So that's why we are using some sources which should be safe to handle and use. Okay. Now the fifth point is which does not cause environmental pollution. Yes, this is the most important characteristics of a good source. It should not produce the environmental pollution. See, you're using the solar energy. Is it producing any pollution?
No, sir.
Not so much, right? Well, it's
Okay.
also producing because the solar panels.
Yes, sir.
So the solar panels which you are using, so see, it has some time period, and after that, we cannot use the solar panels. So it's a type of waste which are producing. Okay, so solar energy is also producing, but it's not up to that level. Okay,
So
hydro
it's very
energy,
minor, sir. for solar.
it's so minor, so it's minor, right? Hydro energy, beta,
So
it's
yes,
not,
sir.
it's
It's
not
like
producing.
a little, sir.
Right,
So a lot of families lose their homes and lives.
exactly. So you
They
have to
get
make sure.
submerged in the water.
Right, Vikram. So you have to make sure that the source which you are using, it should not cause any environmental pollution. Okay, so here are some characteristics of a good source. If someone asks you for the characteristics, you can write these 5 points. Okay, beta.
Yes, sir.
Oh, perfect. So let's move ahead. Let's talk about the fuels. As I mentioned you earlier, that you use some fuels to do some work, right?
Yes,
We
sir.
are
Yes,
using
sir. Yes, sir.
fuels. Okay. So let's talk about something fuels. What is fuel actually? It is the material which are burned to produce the heat energy. See, you know about the petrol and diesel. We are actually burning petrol and diesel so that it will provide energy. It will
Yes.
provide the heat energy, and through that heat energy, better the car moves, right?
Yes.
Car or any
Yes,
vehicle which we
yes,
have,
sir.
right? So fuels are something, are those materials which I can say the fuels are those material which are burned. Okay, we are actually burning these fuels so that we get the heat energy. Okay, so what are fuels? The materials which are burned to produce the heat energy. Examples you can say wood. We have wood, coal, LPG, which you are using at our homes, right? Cooking gas, we can say cooking gas, kerosene, diesel, and petrol. Here are some examples of the fuel which we are using. In our day-to-day life, the most important source of energy are the fuels, right? As you can see here around yourself, so you will find that fuel plays a very important role. Okay, so the I can say like the most important source of energy in today's world is actually the fuel. See, without this LPG, it's impossible for us to cook food, right? Without this diesel and petrol, it's very impossible. It's almost impossible for us, right? Because
Yes, sir.
without diesel and the petrol, our cars will not work, right? We cannot go from one place to another because all the automobile part, right? All the automobiles work on this. And without this kerosene, actually, see, kerosene is not so much important in today's world. But yes, again, coal, the most important thing. Why? Because in thermal power plants, Peter, in thermal power plants, we are using the coal to produce the energy, electricity, actually. So again, coal is important for us because if we don't have the coal, it's almost impossible for us to produce electricity. So now if you say that, sir, we have the hydropower plants, we have the nuclear power plants also. Although we have those plants, but the number of power plants in today's, you can say, in this particular time, the number of power plants you have. So thermal power plant has the greater number as compared to the other ones. Okay. So thermal power plants use the coal to produce the energy. So again, coal is important for us. Fuel are the concentrated storehouse of energy. You can say it is the storehouse of the energy. So in terms of this fuel, you can actually store the energy. Okay. Okay. So through this fuel, if you are using the fuels, or you can say it is a storehouse. Like if you store some fuel, that means you can store your energy in terms of this fuel also. Can we say this thing?
Yes, sir.
Can we say this? See, if you are accurate with this point, just say yes. If you're not, say no.
Yes,
Okay.
sir.
Fuel
So
are
once repeats.
yeah, fuels are the concentrated storehouse of energy. It's something like that. Fuels are something in which it is something like the source of energy we have. You can say it is the storehouse of energy.
Shouldn't it be pronounced fossil fuels?
Sorry, madam.
So shouldn't it be pronounced fossil fuels also, because there's a difference between fuels and fossil.
Forward, beta, forward. Like should be pronounced like what?
So fossil fuels, sir. So because coal and petroleum and diesel, they're all fossil fuels, sir.
I'm not getting. Can you write it on the screen, beta?
Oh yes, yes, sure, sure.
Just write it on the screen.
Oh, sorry, sir.
Fossil fuels. Fossil.
Yes.
Okay, okay. See, yeah, fossil. Of course, fossil. We will use this term also, beta. But in next lecture, we'll talk about the two type of sources. The first one is the renewable sources, and the second one is non-renewable sources. In that non-renewable sources, we will use this part. Okay. So till now, we are just using the term fuel only. Okay. About this fossil fuels, we will definitely study about this part in the next lecture. Actually. Okay.
Okay, sir.
Now, so okay, so I hope you got these points that the fuel is actually a storehouse of energy. Like if you have the fuel, you have the energy. If you don't have the fuel, you don't have the energy. Simply point you can understand this. Okay, so it is something like the energy of the energies. Okay, if you are having the fuel, you are having the energy. Simplest point we have. So here we have the few points related to the fuels. Now let's move on to the next part. For the fuels, another thing which is the energy is released in form of heat only. Okay, so by using the fuels, you can only get the heat energy. Okay, by using the fuels, you will get only the heat energy. Whether it is a wood, whether it is a coal or a LPG, kerosene, diesel, and petrol, in any of the case, if you see, you will get only the heat energy. If you burn this wood, you will get heat. If you burn this coal, you will get again heat from this cooking gas. From this cooking gas, we are getting the heat, right? From the kerosene also, we are getting the heat. From this diesel and the petrol also, we are getting the same heat. So from the fuels, actually the energy which we are getting is the heat. Okay. And how we are getting this energy better? When you burn the fuel, you will get that energy. And the only thing which you can do with the fuel is to burn them. Okay, you can only burn the fuel, and so that you will get the heat energy. See, where there are some varieties of the fuel which are available to us, so we should have some means of deciding which fuel is the best for our purpose. So definitely you have to decide it whether what kind of fuel is best for us. Okay, so you have to decide it also. So accordingly, you will use that fuel. Like in case if I say the petrol is, I think it's see, petrol is best for us, right? Because without petrol, it's almost impossible for us to move from one place to another, right? So according to the use, you will define that which fuel is better for you. Okay. So before we describe some of the characteristics of the fuel, which will help us to choose the best possible fuel for a particular use, we should know the meaning of two terms. The very first term beta here is calorific value of a fuel, and the second term is ignition temperature. Just let's talk about the calorific value of a fuel. See, it's something like if you burn a fuel, that how much on burning of the fuel, how much energy you are getting. It defines the calorific value. If you're getting the more heat, that means the calorific value of the fuel is more. If you're getting the less heat, that means the calorific value of the fuel is less. Okay. So how you will define the characteristic of a fuel, that what fuel is good or not. So you can define the characteristic of a fuel on the basis of its calorific value and the ignition temperature. So let's talk about the calorific value. All the fuel produces the heat energy on burning. We know this part. Different fuels produces different amount of heat on burning. Some fuel produces more heat, whereas other produces the less heat. Right? Agreed, Bachchi?
Yes, sir.
Okay. The usefulness of a fuel is measured in terms of its calorific value. So as I've mentioned you better, the how much the fuel is useful to you guys, it depends on its calorific value. Higher the calorific value, better the fuel will be. Okay, so it's something related to that how much heat it is producing to you guys. Okay, so if the calorific value is higher, better fuel will be better. That means it will gives us more heat, right? And if its calorific value is less, that means the fuel is not so good. That means it will produce a less heat. The amount of heat produced by burning a unit mass of the fuel completely is known as its calorific value. So if someone asks you for the definition of calorific value, so just say the simple thing that the amount of heat produced by burning a unit mass, by burning a unit mass. Unit mass can be anything with that. It can be 1 kg, right? It can be 1 gram. Okay, so it's unit mass. So if you burn a unit mass of a fuel and the amount of heat which you are getting on burning a unit mass of the fuel is its calorific value. Different fuels have the different calorific value, and the value of the value of this calorific value actually it's different, and there's no need to remember those values actually. Okay, so I have a table in which you can see the calorific value of the different fuels, but don't try to just remember it. It's just for the knowledge purpose. Okay,
Yes, sir.
so calorific value. If we talk about the calorific value, so the unit of mass usually taken for measuring the calorific value of a fuel is in gram. Okay, so as I mentioned you better that the unit mass, so unit mass you will take in grams. The unit mass you will take in grams. The mass of the fuel which you are taking is in grams. Remember this point again important. While solving the question, this will be important for you. So we can also say that the amount of heat produced by burning unit mass, but its unit mass you can see 1 gram is unit mass. So actually I have just modified the definition now. I've just modified the definition. Amount of heat produced by burning a 1 gram of fuel completely is known as its calorific value, right? Instead of this unit mass, I'm just using 1 gram because it is mentioning here that the mass usually taken for measuring the calorific value is in grams. It should be in grams. Okay. So just for example, in order to understand this part, let us consider this example. Suppose we have 1 gram of a carbon fuel. Carbon fuel is what? It's a charcoal. It's a kind of a coal fuel. Okay. So if you burn 1 gram of carbon fuel, you'll get energy or you will get a heat of 33,000 joules. How much heat you are getting, beta? It's 33,000 joules. So the calorific value of charcoal is how much? 33,000 joule per gram. According to the definition, amount of heat produced by burning unit mass. So it will be like this. This will be your calorific value. So from here, if you want the formula for this, so calorific value can be written as heat energy upon mass, and this mass has to be in gram. It should be in gram. So if you are using 1 gram of carbon fuel and you are burning it, you'll get 33,000 joules of heat. So the calorific value of this carbon fuel comes out to be better 33,000 heat we are getting on burning 1 gram of the fuel. So it comes out to be 33,000 joule per gram. So this will be the unit for the calorific value. So the calorific value of charcoal is 33,000 joule per gram or right? Can we say this thing? Agreed, beta?
Yes, sir.
Sir.
Are you getting both these points?
Yes, sir.
Do you have any doubt? Any kind of doubt? If you have, you guys have any doubt related to this calorific value, related to the fuel, related to the sources of energy or energy, whatever doubt you have. Do you have any doubts?
No, sir.
Not a doubt. Perfect. So let's move ahead. And another thing which I would tell you that this joule is actually a very small one. Okay. So when it comes to the greater values, this joule is actually a very smaller value. So in order to make it bigger, we actually using the terms kilojoule. Okay. Joule is a very small unit of heat energy, so the calorific value is usually expressed as kilojoule meter. Okay, so we are not using the joule, we are using kilojoule. So the calorific value in this part, it comes out to be how much? 33
kilojoules
kilojoule
per gram.
Okay, so this will be the calorific value of the charcoal, right? Now, the calorific value of the charcoal becomes the 33 kilojoule per gram, which is this part. The common unit for measuring the calorific value is kilojoule per gram. But this is the unit for this calorific values. Okay, so this is the unit of calorific value, which is kilojoule per
Gram.
right? So actually, calorific value of a fuel actually is representing what? What is calorific value? What calorific value is representing actually?
Heat produced.
Heat produced. Exactly. You can say this. It's actually giving us the value of heat produced. See, calorific value of any fuel is equal to amount of heat
The heat
produced
produced by burning it.
by burning. By burning 1 gram of it, right? It should be
Yes,
unit
sir.
mass. It
Yes.
should be unit mass. So heat
By
produ-
burning 1 gram.
yeah, by burning 1 gram of heat produced upon unit mass. So it should be in gram. So it is equals to heat produced. Let's say heat is noted by H and it will be M. M has to be how much? 1 gram.
1 gram.
So this will be a calorie. Unit comes out to be kilojoule per
Gram.
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 Right. So it's all about the calorific value. And if we have two fuels, fuel 1 and fuel 2. Now, the fuel 1 is having the greater calorific value as compared to the fuel 2. So what you will say?
More
Fuel
energy
one
is produced.
produces
More energy.
heat.
Energy, more heat energy. If we burn 1 gram of the fuel 1 and if we burn 1 gram of fuel 2, we will get more energy from
Fuel 1.
as compared
Fuel
to
one.
the fuel. Well,
Yes.
getting this part?
Yes, sir.
Perfect. So here we have the table in which you can see we have the different calorific values for different fuels. There's no need to remember these values. Okay. So if we have the tongue cake, remember this? Okay. In local languages, we call it uple. Okay. So its calorific value is 6 to 8 kilojoule per gram. Wood having the calorific value of 17 kilojoule per gram. Coal having the value 25 to 30 kilojoule per gram. Charcoal having the value 33 kilojoule per gram. Fuel, it is diesel. It is having the value 45 kilojoule per gram. It is for the diesel only. Okay. For the kerosene, it is 48 kilojoule per gram. For the petrol, it's 50 kilojoule per gram. For the biogas, see biogas, we'll talk about the biogas also. It's 35 to 40 kilojoule per gram. Natural gas, it is 33 to 50 kilojoule. LPG, it's 50 kilojoule per gram. Methane, it's again a gas better. Okay, methane is also a gas, and the methane is very harmful gas actually. Okay, so it comes out to be 55 kilojoule per gram. Hydrogen gas, it is 150 kilojoule per gram. So as you can see here, the hydrogen gas is having the very big calorific value, right?
Yes, sir.
So if we want to use fuel, what fuel you will use? Okay, so if you want any of the fuel, so what kind of fuel you will use? See, I will use the hydrogen gas because it is having the greater calorific values, right? If
Yes,
someone
sir.
asks me that what kind of fuel you will use, so I will say like among all these fuels, only hydrogen gas is having the more value, more calorific value, right? That means
Yes,
this
yes,
hydrogen gas produces the more
heat. Then
So definitely, I will go with the hydrogen gas. I will go with the hydrogen gas because it is producing more heat. Okay. Now, from the above table, we'll find that the calorific value of the kerosene is 48 kilojoule per gram. And now by saying that the calorific value of kerosene is 48 kilojoule per gram, that means that on burning 1 gram of the kerosene, what heat energy you are getting? 48
48 kilojoule.
48
kilojoule.
kilojoule.
Well, so the term calorific value comes from the fact that earlier unit of measurement of heat was calorie. See, why we give this term calorific value? Okay, it's all from that in earlier cases for heat we use a term called the calorie. Okay, calorie is also a unit of heat beta. It is also unit of heat. Okay, so since the calorific value is something related to the heat, right? Calorific value is something related to the heat. More the calorific value, more is the heat. So why we give this name calorific? It is related to the calorie, which is again a unit of
Heat.
okay. So that's why we call this calorific value because calorie is the unit of heat, and this calorific value is related to the heat also. Again, it is related to the heat, so we can say yes, we have given this name calorific value. Okay. Now, in today's world, we talk about that almost we use joule as a unit of the heat, but term calorific value continues to be used as a very this forget this part, right? Okay. If we look about the table, what you'll find that hydrogen is having the more calorific value, right? It's 150 kilojoule per gram. So if the hydrogen is having the higher calorific value, that means hydrogen is a very good fuel. Yes.
Yes, sir.
So it's very easy. It's a very good thing if we use the hydrogen as a fuel, because by using it, we are getting the more amount of the energy. So most common fuels are compound of hydrogen and carbon, called the hydrocarbons. Okay. So most of the fuels you will get is a compound. Okay, it's a compound of hydrogen and a carbon, which we call as a hydrocarbon. Each and everything. The fuels which you are using right now in today's world, it's actually a compound is actually a mixture. You can say it's a mixture of hydrogen and a carbon, which we call as a hydrocarbon. Got it, beta?
Yes, sir.
Yes,
It's
sir.
all about the fuel. It's all about the fuel. So what we have studied about this, first of all, we talk about the energy. What is energy? It is the capability to do work. If we have the energy, we can do work. If we don't have energy, we cannot do our work. Then is the energy conserved? Yes, energy is conserved. We cannot create it. We cannot destroy it.
Destroyed.
But yes, we can convert it from one form to another. And for that, I've seen this conversion in that in case of power plants, whether it is a thermal power plant or a hydro power plant. In thermal power plant, we are converting the heat energy into electricity. In case of a hydro power plant, we are converting the potential energy of that water, or we can say the hydral energy of this water, into the electrical energy, right? Then we talk about the fuels, and I say that okay. Then we talk about the sources of energy, like what are the different sources. So I said that we in nature we have different sources, like we have the solar source, we have the light here for the solar thing. We can use the light also. We have hydro, we have this wind energy, right? So we have different sources, biogases and all these things in our surrounding. Then we say what are the characteristics of a good source of energy. So we have 5 points for that. It should be easily available. It should be easy to store. It should be easy to transport. It should have the higher calorific value, right? Okay. We have studied about the 5 points for this. Then we have studied about the fuels. What are fuels? So we say that fuels are something when we burn them, we'll get the heat energy, right? Fuels are some material. On burning of these materials, we will get the heat energy. Okay. So then we'll come to know about the fuels. We say the fuels which we are using in today's world are wood, coal, then diesel, petrol, then kerosene, LPG. These are all our fuels. So if we talk about the fuels, so which fuel is better and which fuel is not better, how will we define it? So we can define it by using the concept of calorific value. Now, what is this calorific value? Actually, calorific value is the value of the heat. If a fuel is producing the more heat, it is having the more calorific value. If the fuel is producing less heat, it will have the less calorific value. So calorific value is related to the heat produced by burning of the fuel. So the proper definition of the calorific value comes to be it is the amount of heat produced when you burn a unit mass of the fuel. Now, what is this unit mass of? It can be 1 kg, it can be 1 gram, but it is saying that whenever you talk about the calorific value, you will take mass in grams. So the calorific value comes out to be how much heat produced on burning 1 gram of the fuel, and the unit for this comes out to be joule per gram. Then we said that the joule is a very smallest unit for this. Okay, joule is a small unit. So just take a big unit for this. So we take kilojoule. It comes out to be kilojoule per gram. This is the proper unit of calorific value. So I must say, if you burn a 1 gram of fuel, then the amount of heat produced is its calorific value, right? Agreed, beta?
Understood, sir.
Okay. So do you have any doubts?
No, sir. No.
Not at all. What about the other students?
No, sir. No doubt.
No doubts.
No, sir.
Okay. Well, so if guys don't have any doubts, so I think it's enough for today. It's a very small session, right? 7:30. Anyways, no problem. So it's all for today's session. Since it is an introduction, it's a very simple thing for us. But yes, from next session, we will go up to the some deeper part, and yes, we'll talk about the some renewable and the non-renewable sources of energy also. Okay. So don't forget to download this Arkmedis app. You have this app? No? If you don't have that, just download
Sir,
it.
I'm
Yeah.
not getting how to download it, sir. It's asking email, but it's not taking that.
Okay, so
So
have
yes,
you,
sir.
Yes,
So
sir.
there seems to be some
We
problem
can
with the,
download, but there is
we cannot
some.
sign
okay,
up.
so you are can
Yes.
you're not able to log in this, right?
Yes, sir.
Okay, so you're facing the login issues. Not an issue, no problem with that. Let me talk my team for this. Okay, and we will resolve this problem very soon. Okay, don't worry.
Okay, sir.
Okay. So I think it's enough for today's session, and yes, we will meet up in the next session. And yeah, also we have to plan for a test pickup.
So,
So
can you
when you are ready for this test?
Sunday?
Sundays?
Yes, sir.
Okay. So let's plan it on the Sunday, the upcoming Sunday. Okay, and it's for sure that on the upcoming Sunday we will have a test of electricity. So be ready for it.
So
Okay,
can
madam?
you inform the group before you?
Of course, I will. Of course, I will. Don't worry. I will inform my team for this, so they will upload this test, and so that you can do this. Okay. And in case of any doubt, you have my contact number.
Yes, sir.
Okay, fine.
So
For
can you
any-
message once in the group, sir?
I don't know the group, but I don't think I'm in the group now. So let me talk to my team for this. Okay.
Okay, sir.
I don't think I'm in your group. I'm not in your group actually.
Okay.
Okay, sir.
So let me talk to my team. So they will add me in your group. So I will give the updates about it. Okay.
Okay.
So that's all for today, and I hope you get all the concepts clear. Okay.
Yes, sir.
So we'll meet up in the next session. Bye bye, guys. Take care. All the very
Yes,
best.
sir.
Bye, sir.
Bye bye.